Look closely. There is nothing here, no light, no heat, no sound, nothing to see at all. And yet, you are looking. This is a place, a single point in space, right here. It has no name, nothing to mark it, nothing to map it against. And it is old, older than you have the numbers to imagine. Once, this point held everything. What you are looking at now is the oldest light there is. The light left over from the moment the universe first turned clear. It has been traveling toward you for nearly 14 billion years. It is a memory, the only one the universe has left, the memory of its own birth. Watch what is happening to it. It is fading, not breaking, not burning, simply thinning. Cooling toward a cold it can never quite reach. This is the last warmth in all of creation, and it is leaving. The universe is not dying, it is forgetting. Soon this light will be gone, and nothing, anywhere, will remember that it was ever here at all. Every ending the universe has ever made has had someone to see it, someone to stand at the edge and watch the light go out. This is the only ending in all of history that no one will witness. Unless you happen to be alive at the one moment it can still be seen. You were looking at nothing. Look again. This is the same point in space, the same coordinate, the same right here, but not the same when. This is now. Nearly 14 billion years after the beginning, the universe is awake. As many as 2 trillion galaxies, near enough that the difference would take a lifetime to count. Each one 100 billion suns, a web of fire stretching 93 billion light years across. This is the richest the universe will ever be. This is its noon. We have measured its age with astonishing precision, 13.787 billion years. Sit with that for a second, not the billions. The decimals, the part we admit we are unsure of, give or take 20 million years, is longer than our entire species has walked the earth. That is the size of our doubt, and it is the smallest it has ever been. We know this thing so intimately, and still there is a crack. Our 2 best clocks, measuring the same universe, cannot agree on how fast it is running, not because we are careless, because something, somewhere in our understanding, is missing. Even inside our certainty, there is a flaw we cannot find. And yet, for all that size, all that light, the universe has lived through barely 1/100% of its life as a place of stars. Not 1%, 1/100%. It is young, a blazing, reckless child, and it does not yet know that it is going to die. To watch what kills it, you will need to put your clocks away. Not seconds, not years, powers of 10, one tick, 10 years. The next, 100, the next, 1,000, each tick 10 times longer than all of time before it. The 10th tick is 10 billion years, and the 10th tick is tonight. This room, this sentence, you listening. There are 90 ticks to go, and every single one is longer than everything that has ever happened, combined. But the universe is not holding still. It is flying apart. A force we barely understand, more than 2/3 of everything that exists, is pushing it all away from itself, and it is winning. Every one of those galaxies is racing toward the edge of what we can see. One by one, they cross it and vanish, not in an explosion, not in fire. Their light simply stretches thinner and thinner, redder and redder, until it fades below the faintest color there is, and is gone, forever. In about 100 billion years, every galaxy beyond our own small neighborhood will be gone from the sky. The Milky Way, Andromeda, and their handful of companions, bound together by gravity against the rising tide, will likely have drawn into a single island of light alone in an ocean of perfect black. And here's the part that should keep you awake tonight. An astronomer born into that lonely island will look up at an empty sky and conclude that their galaxy is the entire universe, small, static, quiet, eternal. They will build their telescopes, they will do their mathematics, they will be brilliant and careful and right about everything they can see, and they will be completely wrong. They will have no way to know the other galaxies were ever there, no way to know the universe was once larger, no way to know it is dying. We are looking at all of it right now. They will see none of it. We may be the only ones who ever get to watch. But it was not always this lonely. To understand what the universe is losing, you first have to see what it once was. So, rewind. 11 billion years ago, this is the universe at its peak. Astronomers call it cosmic noon. It was barely 3 billion years old, and it was on fire. Galaxies collided in the dark, and everywhere they touched, they ignited. At this one chapter of cosmic history, the universe was making new stars faster than it ever would again, 30,000 of them. Every second, hold that, 30,000 suns struck from cold gas like sparks from flint. Every second, for hundreds of millions of years, the universe was a factory of light, and then, the way every fire does, it began to die down. By the time our own sun was born, the Great Fire had already burned past its height. Half of all the stars that will ever exist had already been made. Even tonight, the universe is still lighting new stars, but only about 3,000 a second, 10 times slower than its noon, and falling. Picture a vast library where every star is a book. At cosmic noon, 30,000 new books were written each second. Today, 3,000. In a trillion years, one book every million years. The library is not burning. It is simply no longer being filled. The gas that makes stars is finite. Every generation locks more of it away inside corpses that will never give it back. Until, around the universe's 100 trillionth year, the last cloud of star stuff collapses into the last new star. And there are no more. It is almost impossible to feel how far away that is. So try this. Compress all of cosmic history into one calendar year. The Big Bang on January the 1st. Tonight, the last second before midnight on December the 31st. On that calendar, everything humans have ever written down, every name, every war, every song, every prayer, fits inside the final 14 seconds before midnight. And the smallest stars? On that same calendar, where the whole of cosmic history fits inside a single year, the last of them are still burning 7,000 years of Decembers later. We are a flicker. They're the long, patient dark that comes after the flicker is gone. These are the stars that inherit the universe. Red dwarfs, small, dim, cool. The most common star in all of existence. 7 out of every 10. You've almost certainly never seen one. They're too faint. And yet the nearest star to our own sun is one of them. So is TRAPPIST-1, a tiny ember with 7 worlds circling close around it. A red dwarf is a miser with its fuel. Where the sun burns hot and fast and dies in 10 billion years, a red dwarf hoards its hydrogen, stirring every last drop down into its core, and burns for 10 trillion. It will never swell into a red giant. It will never explode. When its time finally comes, it does the quietest thing a star can do. It fades. By now, the universe is almost entirely red. A handful of deep crimson embers in an ocean of black. the last fires, the last warm things, the few cells still flickering in a mind that has gone almost completely dark. And one of those embers is burning lower than all the rest. It is the smallest kind of star that can exist, 80 times the mass of Jupiter, and no more. It sits in a galaxy long since collapsed into a loose, dark swarm of dead suns, and it is the last star in the universe still burning hydrogen, the last object anywhere turning matter into light, the last fire of any kind in all of creation. No one lights a candle for it. No one knows that it is the last. And slowly, over hundreds of billions of years, it cools. The deep red sinks to a darker red. The darker red sinks to a heat you could only feel, never see. The heat sinks to a glow you would need an instrument to find. And then, wait, because the universe is not quite ready to go dark. It has one last fire saved for the very end. Somewhere in another dead galaxy, a white dwarf, the cold cinder of a sun that died eons ago, has spent an eternity quietly stealing mass from a companion, gram by gram, for ages without number, until one day it crosses a line it cannot uncross, and it detonates. For a few short weeks, one point in the dead universe blazes as bright as an entire small galaxy, the last supernova, the final firework of all creation, a single brilliant flare in a cosmos with nothing left in it to watch. And then it fades. The light pulls back, the dark closes over it, and there will never be another, ever. 100 trillion years, every star that ever shone, out. And the universe has not yet even begun to die. What is left behind are the dead, the white dwarfs, Earth-sized diamonds of crushed carbon, the cooling hearts of stars, bleeding their last heat into the void. Given enough time, they fade all the way to black, cold, dark, crystalline, black dwarfs. And here's something strange. In the entire universe today, there is not a single black dwarf, not one. The universe is simply too young to have finished cooling even one. Every black dwarf that will ever exist is still a glowing white dwarf tonight, waiting across stretches of time that make the whole of human history look like a single flash of light. And drifting between them, the brown dwarfs, the stars that never were, too small to ever catch fire. They do not burn, they do not die, they only grow colder and colder, not alive, not dead, just still here. The last star is out. The universe is dark, truly dark, for the first time since it began. And in that dark, a question. If there is no one left to see it, no eye, no instrument, no mind, does time even still pass? Is a universe in darkness a real, physical thing? Or only an empty stage, with the lights off and no one in the seats? The dark is not empty. The universe has stopped making light. It has not stopped holding things. This is the degenerate era, the age of the dead. Black dwarfs, cold neutron stars, failed suns going colder, an entire universe of corpses drifting in the black. Nothing burns, nothing shines, but everything is still here. Every atom the universe ever built, still locked in its place. And then the universe begins to take that back too. Everything you have ever touched is built from protons. The chair beneath you, the bones inside you, the dead stars in this frame. Your whole life, you have assumed the proton is forever. We are not sure that it is. Our best theories whisper that the proton may not be eternal, that given long enough, it might simply come apart, flash into light, and be gone. For decades beneath a mountain in Japan, we have watched 50,000 tons of pure water waiting to catch a single proton in the act of dying. So far, nothing, not one. Which tells us something staggering. If the proton dies at all, it outlasts the present universe, not by millions of times, but by more than 1 trillion times over. If every atom in your body were a clock, then across the entire age of the universe so far, not a single one of them would have ticked. Not once. And on that one unanswered question hangs the fate of every atom in existence. Because if the proton can die, then everything made of them dies with it, slowly, silently, from the inside out. One by one, the protons in a dead star wink out into radiation. The star does not explode. It does not collapse. It simply thins, dissolving into faint light that drifts off into the dark. And here is the strange, almost funny part. A dead star, slowly dissolving from proton decay, gives off a tiny trickle of heat as it goes, about 400 watts. 400 watts, the entire mass of a star, putting out no more than a handful of light bulbs for trillions upon trillions of years. In a universe of absolute cold and absolute dark, a corpse becomes the warmest thing left, a gravestone that glows. But suppose the proton is forever. Suppose matter is allowed to last. Even then, it does not stay the same. Take one dead world, a frozen planet, far from anything, locked solid at a fraction of a degree above absolute zero. Nothing there moves, nothing there changes. And yet, atom by atom, it is quietly remaking itself. Because there is one form matter would rather be than any other, the most stable thing it can become, the place every atom wants to lie down and rest. Iron. So that frozen world is slowly turning to iron from the inside, over a number of years with 1,500 zeros after it. A number like that is not a length of time you can feel. It is a length of time that makes the death of the last star look like it happened this morning. In the end, the cold, dead worlds of the universe all settle into the same shape, perfect spheres of iron drifting in the dark. And all the while, gravity is tidying up. The dead do not drift in peace. They pull on one another, swing past one another, and little by little, the lightest get flung out into empty space, while the heaviest sink toward the center. Some find partners. Two dead stars, bound since the day they were born, circle each other in the slowest dance in the universe, a spiral that takes 100,000 trillion years to close. When they finally touch, there may be one last spark of fire, or just a silent merger in the dark. Either way, no one sees it. And at the heart of every dead galaxy, the sinking corpses piled together merge and grow until they collapse into the one kind of object patient enough to outlast them all. Whether the atoms dissolved or were swept up, the ending is the same. One by one, the islands of ordinary matter go out, and what is left to inherit the universe are the only structures still standing. Black holes, drifting alone, light years from one another, almost perfectly dark, almost perfectly still. The last anchors of gravity in an emptying cosmos. Nothing out here remembers being a star. All that is left are the black holes, and inside them, the last memory of everything that ever was. They will not hold it forever. This is the last structure in the universe, a black hole, alone. Light years from anything else, almost perfectly dark, almost perfectly still. Inside it lies everything the universe ever lost, every star, every world, every atom that fell in across 100 trillion years. All of it, crushed into a single point of dark. The universe has not destroyed that information. It has locked it away. A black hole is the universe's last vault. And vaults, it turns out, are not as permanent as they look. For most of history, We believed a black hole was forever. Whatever fell in, stayed in. Nothing escaped, not even light. Then, 50 years ago, a young physicist named Stephen Hawking proved something nobody expected. Black holes glow, not from anything falling in, not from heat in any ordinary sense. The glow comes from the edge itself, from the simple fact that a horizon exists. Where there is a horizon, the empty space around it cannot stay perfectly empty. It is forced by the deepest laws we know to leak. Faint light seep in out of the dark, paid for by the black hole's own mass. The universe charges a tax on existence, and a black hole pays it, photon by photon, for an unimaginably long time. The bigger the black hole, the colder it is, and the slower it pays. Today, every black hole in the cosmos is colder than the space around it. They are still feeding, still growing, but the universe is cooling, and one day, the dark around them will fall colder than they are. And from that moment, they begin to lose. The small ones go first. The black holes left behind by single stars take so long to evaporate that the entire history of the universe so far, every star, every age we have walked through, is barely the first tick of the clock. And when one finally empties, it does not fade quietly. The less mass it has, the hotter it burns. The hotter it burns, the faster it sheds what is left, until, in its final instant, it detonates. A black hole that existed for an eternity dies in less than a heartbeat. A single flash of light, brighter than a galaxy, expanding outward into a universe with nothing in it to see. Then the larger ones. Then the giants. Consider one of the largest we have ever seen. The black hole at the heart of the galaxy, M87, 6.5 billion times the mass of our sun, wider than our entire solar system. A monster we have actually photographed, a ring of light around a wound in space. It will take that black hole 10 to the 97th years to fully evaporate. On the clock we built at the start, the clock where every tick is 10 times longer than the last, that is 87 ticks beyond tonight. 87. And it is one of the last things the universe will ever do. But this raises a question that has haunted physics for 50 years, and it is the deepest question in this whole story. When a black hole finally evaporates, when the last photon of its glow drifts away, what happens to everything that fell inside? All those stars, all those worlds, all that history. Is it still written, somehow, in the faint light that escaped? Or is it erased, as if it had never been? Hawking's first answer, in 1976, was devastating. The information is destroyed, completely, forever. And that broke something, because the rest of physics insists information can never be truly lost. One of our deepest laws and one of our deepest objects could not both be right. For nearly 30 years, Hawking defended that answer. Then, in 2004, in a lecture hall in Dublin, he stood up and conceded. He had changed his mind. The information he now believed is not lost after all. He had once made a bet on the question, and to settle it, he handed the man who had bet against him a single, ordinary thing, an encyclopedia, a book you can open and read and find any fact you want, because the information inside it is never, ever lost. It was one of the most famous reversals in the history of science, but conceding that the answer exists is not the same as knowing what it is. Physicists have spent the years since chasing the mechanism through some of the strangest mathematics ever written. The debate has not ended. Strip away the mathematics, and what is left is almost unbearable. The last light leaving the last black hole carries off the final record that matter ever existed. The universe is not just dying, it is coming undone, unwriting the story of everything it ever held. A death with no witness, a life with no record, the universe unreading itself. And then the last giant reaches its end, the final vault, the final memory, the final gravity in the universe. Its glow has been brightening for an eternity, and in one last instant, it is gone. No more black holes, no more matter, no more structure of any kind. For the first time since the beginning, the universe holds nothing that is holding on to anything. Space-time itself at last, flat, empty, still. Before we follow the universe down into that long, quiet dark, there is something you should know. It might not get there, because there is a faster way for a universe to die, and it could begin at any moment, even this one. The empty space you are sitting in right now may not be as stable as it looks. Our best physics hints that the vacuum of space might be resting in the wrong place, not at the very bottom, but in a shallow dip partway down. And things that rest in dips can fall. If it ever falls, anywhere, even once, a bubble of true vacuum is born. Inside that bubble, the laws of physics are rewritten. Atoms cannot hold together, matter cannot exist, and the bubble grows outward at the speed of light, which means you could never see it coming. No warning, no flash on the horizon. The edge of the bubble travels exactly as fast as the light that would have warned you of it. It could already have happened. Somewhere out in the dark, the end may already be racing toward us. And we would have no way to know, right up until the instant it arrives. At which point, there would be no one left to know it. But set that aside. It is a knife in the dark, and it may never fall. The most likely death is not the sudden one, it is the slow one, the quiet one. So let us follow the universe all the way down. No stars, no matter, no black holes. Space-time stretched flat and empty in every direction. And it is colder than anything that has ever existed. We have a name for this. We call it heat death. It is the most misunderstood idea in all of science. Heat death is not the universe running out of energy. The energy is still here. Almost all of it. Heat death is something stranger. It is the universe running out of differences. Everything that has ever happened, every fire, every storm, every heartbeat, every thought, happened because somewhere was hotter than somewhere else. Heat flowing from high to low. That flow is what drives the universe. Heat death is the moment that flow finally stops, not because everything is cold, but because everything is the same. Every point in space exactly as warm as every other point. Nothing higher, nothing lower, nowhere for anything to flow. A universe where nothing is hotter, nothing is colder, nothing is ordered, nothing is special. The death of the universe is the death of difference, and nothing that is the same everywhere can ever change again. But the universe is not quite finished. There is one last thing it will ever build. Scattered across the void are the final survivors, lone electrons, and their mirror opposites, positrons, the last loose particles in existence. Once in an unimaginable while, across distances beyond comprehension, one electron drifts close to one positron. And they find each other. They circle. The smallest, faintest pairing of matter possible, the last two things in the universe ever to touch. Physicists have a name for this final pairing. Positronium. The last atom the universe will ever hold. Not matter joined to matter, but matter bound to its own opposite, something built from the first instant it forms to destroy itself. And then, in a fraction of a second, it does. A single, faint flash. Two particles becoming one last little ghost of light. That is the last chemistry the universe will ever perform. The final reaction, the final event with a before and an after. After this, nothing the universe does will ever change anything again. And here, we lose the last thing we have, the most fundamental thing of all. Time has a direction. You feel it in every moment. The past is behind you, the future ahead. A glass shatters and never unshatters. That is how you know which way time is pointing. But that direction was never a law of physics. It was a side effect. Time runs forward because the universe runs from order toward disorder, from difference toward sameness. The shattered glass is just more disordered than the whole one. That difference is the arrow. At heat death, there's no more order to lose. Disorder is complete. Sameness is total. Nothing is more disordered than anything else. No before looks any different from any after. And so the arrow has nothing left to point at. Remember the question we left in the dark, back when the last star went out? Whether time still passes in a universe with no one to see it. Here, at last, is the answer. It is not that time stops. It is that time loses every reason to point one way instead of the other. No change, no sequence, no next. An eternal, motionless present with no one inside it and nowhere for it to go. And yet, even perfect silence is never quite empty. The vacuum trembles faintly forever, tiny flickers rising and falling in the dark, too small to matter. But give it infinite time, and too small to matter stops being true. Once in a near eternity, those random flickers happen to fall into a pattern. For a single moment, the noise arranges itself into something that looks like a thought. A pattern that, by pure accident, believes it remembers being someone. Not a rebirth, not a soul, just noise, briefly pretending to be a mind, and then going quiet again, having meant nothing to no one. Across eternity, the empty universe does this again and again, assembles a ghost of a memory at random, and loses it before it can ever matter. And then there's the strangest possibility of all. One of the great minds of physics noticed something. A universe that is utterly empty, no matter, no clocks, nothing left to measure anything against, has no way to tell how large it is. Look at that lonely glow. Is it vast? Is it tiny? With nothing beside it, there is no way to say. And to a universe with nothing left to compare, the infinitely huge and the infinitely small become the very same thing. Having lost everything else, the universe finally loses even its own size. And a universe that no longer knows how large it is looks exactly like the hot, dense beginning of a new one. The end becoming a beginning. Death becoming a Big Bang. It is a beautiful idea. It might even be true. But we have no proof. The evidence has not been found. So it stays where it belongs. The last thought of a dying universe, dreaming for an instant that it might wake up again. But a flicker is not a future. And a door that no one opens is only a wall. One by one, even these last embers go out. And what remains is the quiet. A universe stretched perfectly flat, perfectly cold, perfectly even, holding still in a present with no direction for a length of time that no number can honestly describe. Not destroyed, just finished. Everything that ever burned, everything that ever lived, everything that ever wondered what it all meant, gone and unremembered. This is perfect silence, and it is, almost certainly, how the story ends. Almost. Everything you have just seen, the cold, the dark, the silence, all of it lies ahead, trillions of years ahead. But it has not happened yet. So let me take you back, all the way back, not to the beginning, to now, this place. The same point in space where we began, empty and cold and dark. Look at it now. Here in this moment, there's a star, and around that star, a world, and on that world, someone is watching. At the very start, I told you something, that this is the only ending in all of history that no one will witness. That is still true. But there is a second truth, and it is just as strange. Right now, this brief, blazing moment is the only time the whole story can be seen at all. Tonight, the evidence is still here. The galaxies are still in the sky. The oldest light still glows, faint and warm, in every direction. The whole history of the universe is written above us, and anyone who looks up can still read it. But the universe is flying apart, and one by one, those pages are slipping over the horizon, out of reach. The minds that come after us, trillions of years from now, in their lonely island of light, will look up at an empty sky and never know the universe was vast, never know it had a beginning, never know it was once full of fire. The window is open now. It will not stay open. We are not living at an ordinary moment. We are living at the only moment, the one time the universe can be known by the one thing in it that can do the knowing. Nearly 14 billion years. Stars that lived and died to forge the atoms in your body, a cooling world, a first spark of life, a chain of minds unbroken all the way to you. The universe spent its entire youth building the one thing that could witness it, something that could look up, read the sky, and hold the memory the universe cannot keep on its own. That witness is us. That moment is now. Which leaves one last question, maybe the only one that ever mattered. If all of this disappears without a trace, did it matter? Physics does not answer that question, but the fact that you are asking it, that already says something. A stretch of time so vast it has no name, emptiness on every side of it, and somewhere in the middle of all of it, you. The universe will not remember that you were here, but for one moment, you were the part of it that could remember everything else.